Okay, so I got a question about MIDI and how it should work in BB. So um, first off, the note in object is what we should look at. So if we look at note in, it's got a help file. It's a bunch of stuff here, but basically we're looking at notes right now. So just note in. So the help file brings up lots of different MIDI objects. But note in has 3 outlets. So you got MIDI pitch, MIDI velocity, and channel. And we could also specify a channel. So if we specify channel 1, we only have pitch and velocity to worry about. So that's the help file. Now, another thing to look at is MIDI settings, and making sure whatever your MIDI device is appearing and picking that as an input device. So that's the MIDI input device that I'm using right now. So it's a MIDI keyboard, and it's detecting that already. But if it isn't, come here and make sure you're detecting the right thing. Okay. Go ahead and specify channel 1. So now I only have pitch and velocity as output. So I'm going to connect a couple of number boxes to those outlets. And so when I play my MIDI keyboard, so if I play middle C, I get maybe note 60, and velocity is going to be different depending on how hard I play the key. When I release, I'm going to get a 0. So that 0 is really important because it tells us when to start a release. So if we're using V-line for an envelope, we've got attacks, we've got releases. So we use an object called select to select for that 0 and do a specific thing. So I have a select, which I can abbreviate that with SEL, and I'm selecting for the number 0. So when I get a 0, I want a release because it means I've released the key. I let go of the note on my keyboard, and so that's why that 0 is happening. And so I want to send V-line a release ramp. So I could say a message box 0 and go to 0 over some amount of time. So in my AADSR, this is my R, this is my release. So for everything else, anything that does not match this value comes through unchanged out of this outlet. So when I play, velocity of 75, I'm going to get a 75 out of this outlet. Now when I do a release and this matches 0, I get a bang. And so the bang triggers this message box. And so I can connect that to V-line. But when I play a velocity here, I know that the max value I can generate is 127. So when I play a note, it's going to be something between 1 and 127. And I don't want my V line, if I'm using it for an amplitude envelope, to be going up to 127. I want it to go, somewhere between 0 or 1, or maybe even less than 1. But let's say I wanted to go to 1. If I want a range that is between 0 and 1, once I get to V line, and the range that's coming in is between 1 and 127, I can divide by 127. Because 127 divided by 127 is 1. So that means the largest amplitude I would get would be 1. So I can say divide by 127. Okay, so I'm dividing by 127, and now I can say, give this another message box, and now I can use a message variable. Say $1 is a message variable that says the first element that I receive, put at this position. So I can say go to some value scaled from this MIDI velocity to the first position of this list. And then I can say, this will be an attack, and it will be some amount of time. And I can connect that to the line. So now when I attack, I get some amplitude that is scaled to the velocity, so the pressure of the MIDI note that I play. And when I release, I go to 0 in 1 second. So it fades out, and the fade starts when I let go of the note. So my sustain, as long as I'm holding the note, I'm sustaining it. So I don't have to specify a sustain. So I've got an attack, I've got a sustain whenever I hold the note, and I've got a release when I let go of the note. On this side, this is quite a bit simpler. I get a MIDI note, and I convert it to frequency. And I give that value to my oscillators. And I multiply the output of my oscillator by the output of my envelope. And so I get a tone that is going to increase in amplitude when I attack, and then decrease to 0 when I release the note. Alright, so other things to look out for here is, if we had multiple partials, we could approach that in a number of ways. If we had one envelope for several partials, we could say times 2, etc. We might put another amplifier between each oscillator to say, I want this partial to be stronger than this partial. So we would, if we had, say, another oscillator here, we might have another instead. That one's only 0.1 strength compared to this one. We could specify, specify our ratios with another gain stage that way. And each oscillator would have its own specific amplitude. Compared to the other oscillators and the tone. So this could go on, times 2 or times 3, and we'd specify different relative amplitudes for each one.